So you can do weekly production. So pretty much, once you get a hold of the data, there's a bunch of ways that you can use it to visualize it. And we'll get you all of these links, so you'll probably get a memo with this. Now, this is El Paso Electric's outage map. So if, in case you didn't know, there is actually an outage map, so that will let you know if your house is about to get an outage or something. So for instance, they will put out a mark on the map and they will say, well, this outage is going to affect this amount of people. So they go by colors, and then when you hover over that point, it tells you, well, there is the reported sign and this is what's going on. Now, yesterday, and I don't think Dr. Martinez have seen this, we went through the EcoFirst website, and that's a really fancy way of displaying the information. So they're also doing energy consumption, and kind of what Dr. Martinez was mentioning, so you can figure out, well, what I saved was equivalent to not driving this amount of miles, and is equivalent to planting these trees, and then here is your energy consumption, and this one combines heating and electricity. So I will anticipate that since we're doing electricity and maybe water or maybe gas, we still don't know, but we'll get back to you on that. But we should be able to visualize it doing something like this. Then once again, energy consumption here, and look how they also have the alerts. So this is not something new. We're not coming out with the newest product on the street, but that's something that the university needs. So we're trying to provide a service to the university. Now, for this specific example, they are really, really specific on the sort of things that you can do. So you can do monthly analysis, you can do weekly analysis, and if you have your iPhone connected to the system, you can actually change the temperatures and do a bunch of things from here. Okay, so as far as I know, and correct me if I'm wrong, we're not controlling any equipment, right?
No.
We're just processing data
Right.
and visualizing data.
Yeah, I mean, controlling equipment is another level of implementation, but here you're just doing monitoring of the sensors, the smart meters.
So what I will recommend is, and especially for next semester, once you start implementing, start looking into ways to show the information a little bit more fancier. Because the easiest way to do it will be to just go with Java and just do text boxes and a pretty picture there. But for instance, if you go with Flex, if you go with Adobe Flex, you will be able to do stuff like this. So this semester, you will be doing a feasibility report to pretty much to figure out if the whole project is, if we can do the whole project. So what I will recommend is that once you go into that exercise, start looking at some programming languages that you can use to display the information. The other thing is going to be how are you going to process the data. So most likely you're not going to come out with your own implementation to process the data. There's already a bunch of packages out there that does that for you. So you have to do is get that package, figure out how it works, and use the results to visualize the data. Okay, and that's going to be part of the feasibility report.
Let me make a comment while you're on this slide because it's so interesting. This thing here, the miles not driven and trees planted. One of our students did a study on campus. It took them 1.5 years to do what we call the greenhouse gas emission baseline study. We wanted to figure out how much the 6 toxic gases the campus emitted. Okay, and so we did a lot of analysis on all sectors of the UTEP campus, buildings, special events, Haskins, Sunbowl, those things, parking and transportation, food services, electricity, gas, water, fertilizer consumption on the lawns. You spread nitrogen on and it releases gases, and so we did probably about 9 sectors of the UTEP campus. And one of the things we found was an interesting comparison is the student made a comparison over the last 4 years, 2010 to 2006. So we used the 2010 data. we had an increase of 14,000 metric tons of CO2 because we're building more buildings, we built more buildings, so the level of, the amount of CO2 gas emission by those new buildings was added to it, contributed to the CO2 emission. And also we had more students, so more commuters, more gasoline cars and things. And so you figured an equivalent, this 18 trees planted, in order to mitigate those 14,000 metric tons of CO2 by planting trees that release oxygen and use up the CO2, you have to plant 661,000 trees to be able to mitigate 14,000 metric tons of CO2. So it's kind of mind-boggling when you think about it, that we're releasing not only UTEP, but all the buildings and campus and the cars and stuff and the city is releasing that much carbon dioxide into the air. And we're not a big city. You think about Tokyo, New York City, some of the big metropolitan areas that really release a lot of CO2 in the air. So it's kind of, it explains why the CO2 levels in the atmosphere are continually increasing every year. It's just a thing that triggered my mind on that stat.
Now, is there anything on this screen that you would like to see in your system?
Well, yeah, I think, stuff like this is always really good to have, and I think this is where you guys can really put your innovative thinking hats on to be able to come up with different ways of displaying data. Remember that this data should be visualized in the operations center. It should be visualized from a web interface at home, or if I'm on travel in a hotel somewhere, or I can visualize it in a mobile app. So, some apps just aren't conducive to mobile phones and vice versa. So, and you might think of animation and also video representations.
Okay, now I'm going to open up the floor to the classroom, and are there any questions that we left out that you would like to ask?
Questions?
Yes.
Go ahead.
All right.
What format will the data be provided to us?
The formats?
Yeah.
The formats for the data depends on the sensors, right? Whether it's a smart meter, a solar panel inverter, or a building. So the formats of data are usually in a serial byte string like this. They'll have maybe a destination address, a source address, a control field, a data field where we insert all the data, and then what's called a cyclic redundancy check. So these are not used all the time. This just checks the validity of the data as it's transferred from one unit to another. This destination address may be 8 bits. So it's starting from smart meter number 1, and it's going to database port number 23 or 24. Control, this is tells you what kind of data and settings are at the smart meter. This is the actual kilowatt hour data. In here, there may be a timestamp. And then the cyclic redundancy check, the CRC. This is usually 8 bits. This can be anywhere from 0 to 1,500 bytes. And this is usually a 32-bit field. By the way, this is a typical MAC, what's called a physical layer frame for an Ethernet. Some of you have looked at the Ethernet layers, the physical layer. So it'll look like that, and it'll be, the data itself will be either in integer form, or it may be in scientific notation, you know, with a decimal point and then a exponent.
To add to this question, are we gonna be provided with a sample data?
Yes. Yeah, you can get the data from the smart meters and also from the inverter it'll give you a profile of the sample data and also histograms like you saw in the chart of 24-hour periods for the data.
For the data that's being displayed, I know you want a mobile app and a web application. Are there any differences that you expect between the two?
You know, I think, I don't know that much about mobile app programming, but it seems to me that the main difference is the data and the graphic of the data is the same, the algorithms are the same. What's different is the display pixels that are available to you. Right, so in a mobile phone, you may only have 2,000 display pixels, where on a big screen, you know, like a 72-inch display, you might have 4,000 pixels of it, or 5,000. So I think it's just the size of the pixel representation of the display device.
Right, so like, for example, do you want, because obviously there's space constraints.
Right.
So are there particular things that you want to see that are more important so that you can put them on the mobile app compared to some?
Yeah, so I think that's where your innovation comes in. You have to recognize what is the critical information that I would want to see on a mobile app versus all the information that I can see in a control room display. Right? But even with a mobile app, you can still have the hierarchy of views, of display views, right? So, but it depends on what you identify as the critical data. And going back to that picture that was up there, you may not be interested in seeing the house, but you want to see the graph. Or you want to see data points, critical points on the graph. Questions?
And last call.
You were talking a lot about the security and such, but how many different layers of security do you want? And is it dependent on what kind of access you're going to have to the information?
Yeah.
You said we're not going to be doing control as far as like the solar panel. You don't want to